all, welcome back. So in today's video we are going to talk about interface, which is a very important concept in System Verilog. Interface is the concept which was introduced in System Verilog. In Verilog we don't have this concept. So in today's video we are going to talk about what is interface, what is the need of interface, actually why this concept of interface was introduced in SV. So all these things we are going to talk about. And if you are new to this channel, please consider subscribing my channel and hit on the notification bell also. And if you are a person who want to enter into design and verification domain, then this is the right platform for you. You can learn courses related to design and verification domain in my channel. So consider subscribing it and also share it to the VLS aspirants who also want to enter into design and verification domain. Right? So coming to today's topic, which is interface. Basically, in Verilog, when you want to communicate between one module to another module, or when you want to communicate between design and test bench, how you are going to do it? You are introducing a ports like input port, output port, so in out port. So by using the ports, the communication is done between one module to another module, or like one block to another block. So but when it comes to System Verilog, since we are going to design a complex circuits, so the number of ports that we are using will be, the number of signals that we are using are being increased. Okay, so whenever the signals are being increased, it is not very realistic in order to introduce it in the manner of ports. Why is it? Because for example, when you want to introduce any signal into your particular circuit, or when you want to delete some signal, or when you want to remove some signal from your circuit, so what you will do, if you are not having the concept of interface, so from wherever you have instantiated this module, because module or any block you will be instantiating it in number of places, is it or not? So if you are adding any signal, you have to make changes in all these places in order to add a signal, or if you are removing a signal, you have to change in all these places in order to remove your signal. So which is why it is becoming really unrealistic in order to do in such a way, which was why in System Verilog a concept named interface was introduced. So interface is nothing but, this is just like a bus. So in bus, what you will be doing, a bus is nothing but a group of signals. You will be taking the group of signals and you will be connecting the bus from one component to another component. Similarly, interface is nothing but, it is a bundle of all the set of signals are being encapsulated within a component called interface. Okay, so by using this interface, so now it becomes very easy. Why is it? Because you are keeping all these signals, like if you see here, these are the signals. For example, if you see this component, this is the Verilog, this is how we were doing it Verilog. Like every signal we were connecting it individually. So whenever you want to introduce some signal, what you have to do, you have to introduce signal in all the places where this particular signal was, where this particular instantiation was done, is it or not? So in order to avoid this, what we are doing, we have named a concept called interface. So in interface, what we are doing, we are placing all the signals at one place called interface. So whenever you want to add a signal, what you can do, if you are just adding it in interface, then the since the interface is having the all the signals, so in this way the signal is also added here, and then we don't need to make changes in the remaining places, is it or not? So that is why interface was introduced in System Verilog, because the signals are more in case of complex designs, and it is not realistic in order to make changes in this all signals at a time. So which was why interface was introduced, right? So this encapsulates signals and communicates with design test bench components. So whenever you want to communicate between design and test bench, you can just introduce those signals all together within the interface, right? So let us see some more things about the interface. So this is how your, if you are seeing, this is the test bench architecture of SV, is it or not? So within this test bench architecture, this is the interface. So basically the transactions that the generator is driving to the driver is sending them to the DUT through interface. So all the signals are going through to the DUT through interface, and from DUT whatever signals that are that we need to send it to the monitor, those all signals also they are coming through interface to the monitor. Okay, so basically this interface is the component that was introduced in system Verilog. Let us see some more things about the interface. Like we have already talked about interface. Interface is nothing but a bundle of wires. Okay, the interface aims to in order to communicate between one component to another component, like one module to another module. Also, if you want to communicate, what you have to do, you have to pack all this bundle of wires within the interface. Okay, it's just like a bus. So within the interface, what you can write and what you can't write, basically, just like, for example, within a module, what you will be doing, how you will be writing the code, you will be writing within module and end module, is it or not? For function, what you will be writing between function and end function, right? Similarly, for interface also, you will be introducing all your signals within interface and end interface. Okay, so whatever signals you want to introduce within the interface, you can introduce them within the interface and end interface keywords, right? So within the signals, if you want, you can just mention either the signals itself, or you can also mention the port, like directions, like whether it is an input port or whether it is an output port. You can also declare it within the interface, like by using the mod ports. Okay, and you can tell the timing information like clock signals and all also you can introduce within the interface by using clocking blocks. Okay, mod ports and clocking blocks, this is another concept within the interface, we'll be discussing it later. So basically within interface, if you want to know the direction of that particular signal, you will be doing that by using the mod port. If you want to see the timing information of that particular signal, if you want to mention the timing information of that particular signal, you will be doing that by using the clocking blocks. Okay, we'll be discussing it in deep in the later sessions, right? So this is the thing that we'll be having within the interface. So if you see here, just as I told, you will be writing everything within interface and end interface and interface name, and then the signals, whatever signals you want to mention, you will be mentioning, and then end interface. So within these signals, what are the things that within the interface you can have parameters, constants, variables, functions and tasks. So all these things you can include within your interface. Okay, right? As I told you, interfaces are declared using the interface keyword, and the declaration ends with end interface keyword. Okay, and one more important thing within the interface is it is recommended to use logic data type for all the nets in an interface. So basically you will be using the logic data type within the interface more than net, like wire. Instead of using wire or reg, mostly you will be using logic, which why I will also discuss this in this video. Okay, why we are using logic, I will also tell that reason. So basically this is how you will be writing a basic interface, like interface name, like just I'm keeping it as bus. So within the argument you will be mentioning the signals. Okay, if you see here, and within the argument I'll be mentioning some signals, and inside the interface you can introduce some more signals. So basically what is here is, you can just introduce all the signals within the argument itself. Like if you see here, input, clock, and then you can just introduce logic, address and logic, you can just introduce everything here, and you can just give it as end interface. There is no problem in that. But basically, since you will be having many number of signals, and which is why, in order to improve the readability and also due to some other reasons, basically within the argument of the interface, clock or reset signals will be given, and and the rest of the signals like address, data, enable, any other signals. So all these signals we will be introducing within the body of the interface, right? So this is how you will be writing a basic interface. So whatever signals you want to introduce, you will be introducing within the interface in this manner, right? So this is the basic interface. As we already discussed here, we can use parameters, constants, variables, functions, everything. Okay, so one more example for that. Like if you want to introduce a parameter within your interface, how you are going to do it? Just what you will do, interface bus. Okay, along with the input, you will also introduce the parameter here itself. You know that in order to introduce a parameter, you should use a hash mark. So hash, what is the parameter you want to introduce, and you will be introducing here and then input. So you will be mentioning the remaining signals in this manner. Okay, in order to introduce a parameter, you can write it in this way, right? You can also have like as others, if we see variables, functions, or tasks, this also we can write within our interface. Like we'll be seeing the example so that you will understand what is the interface, like how we are writing the interface in real time. Like when you are writing a code of a adder or else something within the system verilog test bench, you will be knowing how to write an interface. We'll be discussing that also, don't worry about that, right? So coming to some of the advantages using interface, okay, or the traditional connection means nothing but using ports. Instead of using ports individually, if we are using an interface, what is the advantages? So first thing is, allows number of signals to be grouped together and represented as a single port. So instead of having many number of ports, okay, if you are having some five number of ports, instead of five signals, instead of having five ports to that five signals, what you are doing, you are just encapsulating all these five signals within one interface. So which is why you will be having only one port. This is your input port, this is your output port. Okay, since this is your interface, the interface consists of the remaining signals. So that is why and since you are encapsulating all the signals within one port, so that is why there is no need of mention, okay, the how many ports, like we are having some 100 number of signals, you don't need to connect 100 ports for this, right? So which is why this is the advantage of interface. Interface declaration is made once and the handle is passed across. Okay, basically, why we are introducing this interface? Why is it? Because if we can reduce the, there are two. First, we can reduce the usage of number of ports, because since we are encapsulating all the signals in one port itself. So that is why you are having one port, and also within the signals also, since you are encapsulating all the signals with the name of interface, so that is why whenever you want to use all the signals, instead of you mentioning all the signals by names, you can just use the handle of this interface so that it will be easily passed. Okay, you don't need to write all the, you mention all the signal names and all, right? We'll be discussing this in detail with example in the like in the later slide, right? So this is the second advantage, right? And the third thing is, same interface can be reused for different projects. Like once we have created the interface, by we can use the same interface, because interface is nothing but this is just a component where all the signals are present. So what we can do, we can just create a handle for this particular interface and we can use it wherever, we can instantiate it in wherever place we need it, right? Addition and deletion of signals is easy, because uh, if we want to add a signal, you don't need to again check whether in which where we have to connect the port. And if we are using that particular signal in some, we have instantiated that particular module in some other component, then we don't need to check, okay, so where is that component, so where, so that we could just again instantiate it there. In this way, you don't need to make all these things. You can just easily add any signal or remove any signal by just going to the interface, and you can just do it as simple as that. So that is why these are the advantages of interface over the traditional connection. Now let us see this with an example so that you can easily understand like the need of interface in one go, right? If you see, this is my full adder code. Here if you see, I have mentioned it in a title, this is the code without using interface. Okay, so this is the full adder code using two half adders. Okay, you already know about the full adder code using two half adders, right? So this is my first module, this is my half adder. So this is some logic. So basically what my half adder consists of: inputs A and B, outputs sum and C naught, S naught and C naught. So this is some logic related to full half adder. Now full adder, again I have to mention all the port names. Okay, even though I have mentioned it in my half adder also, so wherever I am connecting, wherever I am writing the logic, wherever I am writing the module, I have to connect all the ports. Again I have to mention all the ports like A, B, C, some C out, and then some other logic for full adder like instantiator and everything. So now if you see, this is my module, this is my RTL code. And when coming to test bench, so again in test bench you have to mention all the signals, like even though the signals are present in full adder modules also, full adder half adder modules, again you have to mention all the signals here. And then whenever you are inserting, if you see here, you are connecting the test bench to DUT by placing this particular instantiation here. So what you are doing, again you have to mention all the signals that are present. So if you see, the same signals, like these are A, B, some S naught, again the same signals, again this. So in this way you are repeatedly using the connections, you are repeatedly mentioning the signals, you are repeatedly using the port connections. So which is why there are, if for example, since this is only a full adder, you are having basic three input ports and two output ports, so it is fine. For example, if you are considering for some 30 or 40, for example some 60 signals you are having. Okay, so so whenever you are instantiating that particular module, or whenever you are using the module, like if you see here, this is the half adder module, so I am instantiating the half adder module for two times here. So in this way, wherever you are using this particular module, you have to mention all the signals within that module. In this way you will be having lot of port connection. So which is why you will be confused, and also this is not the realistic way to do than to write a code in such a manner, which is why interface was introduced. So what is the use of this interface? So let us see now. The same code, if you see, I have mentioned like A, B, sum and S naught. Okay, so this is my basic half adder. So A, B, sum and S naught. So this is first introduction of my signal ports, like these are the signals basically. So with these signals I have introduced, and I am writing the logic. Now when it comes to full adder, if you see here, in the before slide I have mentioned all the signals, but here if you see, I have just mentioned the interface. So what is it? Within my TB code I have introduced the interface signal. So what I am doing, within the interface I have named by interface as FAIF. Now within the interface I am adding my all the signals like A, B, C, sum and cout. So in this way, how many signals they are there in your particular design, so all the signals you can introduce within your interface, and then interface and interface. Now what you are doing, whenever you want to use these signals, you can just simply use the particular interface name and create a handle for that, and by using this handle you can just make the connections, just as simple as that. So here if you see, instead of mentioning all the name signals by checking whether, because port connections is not as simple as you think, because you either you have to connect it in the same way, same order, or you have to mention it. You already know how the port connections are there, is it or not? Like port connection by order or port connection by name. Okay, so in this way, by checking the order or by checking the name, you have to do connections and everything. But by using this interface, you can just blindly connect the ports by using the interface handle. Okay, so in this way, this interface, by using this interface handle, you can write a basic full adder code in such a simple manner. Okay, in test bench top module also, like in the actual test bench code also, if you see what I am doing, I am creating a handle for this particular interface. So FAF IF, okay, INF is my handle, right? So instead of, if you see here within my test full adder, what I have done, I have mentioned all the signals that I am mentioning within my particular full adder code. So instead of doing all this, what I have done here, I have just given the INF interface handle. That's it. Okay, I have just mentioned the interface handle. So what happens? Whatever that is there within this interface, all this will be connected here. Okay, just as simple as that. And also when you want to throw the values into it, since you are declaring all the signals within the interface, so whenever you want to throw the values or whenever you want to use the signal, basically you have to do it through the interface, because you are taking all the signals within the interface. So you need to take the particular address of this interface. So basically address of interface is nothing but by using the handle dot. Okay, for whatever port you want to, in whichever signal you want to assign the value, you can just assign the value by taking interface reference. That's it. Okay, as simple as that. In this way you will be using the interface. This is the need of interface in system verilog, right? Clear? So now let us see how we will be writing the interface within our system verilog. Okay, if you see, this is all related to verilog. Now within the system verilog, how you will be using the interface. So I have made it in a step by step manner so that you will be easy to write. You already know writing interface. How you will be writing interface name, and whatever signals you will be declaring, and then end interface. This is how you will be writing the interface, right? And then interface declaration means wherever you can, if you want to use the interface, you have to declare that interface, nothing but you have to make a handle for that interface. So this is my interface name. Okay, by taking the name of the interface, you will be declaring the handle for that particular, creating instance of the interface. Okay, intf. Okay, so now what happens, whenever you want to use this interface, like connecting interface with design, because if you see here how you will be connecting within, in this way you will be connecting your design to your test bench. So how you will be connecting your design to the interface, this is how you will be doing. So address, okay, adder. Okay, for example, if you are writing a code for adder, dut instance, and dot a of intf dot a. So why is it? Because this is the design thing and this is the interface signal. So in this way you will be connecting all the signals, design ports to the interface ports in this manner. Okay, and then accessing interface signal, that means whenever you want to assign value to the signal that is present in interface, before only I have told you, you have to do it by using the interface handle. IINTF is the handle of that interface. So IINTF dot a equal to 6, that means a value will be 6 in this way, b value will be 4, right? So this is how you will be writing the this is how you will be using the interface within the system verilog. Okay, so basically this is the interface, and again within the interface we will be having the virtual interface. Okay, so we'll be discussing in the next class like what is the need of virtual interface, and what is the difference between virtual interface and interface, and the and also mod blocks and clocking blocks, right? So this is about interface. If you are having any doubts related to interface, you can ping me in the comment box. Interface is very important in system verilog. So that is all for today. Thank you all.